right? We stopped here on Wednesday. We stopped talking about we were talking about carbonyl addition and how granules add to carbonyls to give you alcohols, and how if you have a specific type of carbonyl, like if you have a ketone or aldehyde, you're either going to get a secondary alcohol with aldehyde, or tertiary with a ketone or with an ester. It's depending on the stoichiometry. So hopefully you had a chance to look at the videos that I sent out the other day to kind of reinforce what we were discussing, and to prep for this morning, because we're going to talk about retrosynthesis. I'm going to go back to a problem here. I'm just going to cut it. And put it on another page. All right. Can't believe September is already over. Wow. All right. So the term retrosynthesis is basically working backwards, right? That's in so many words, it just simply means to work backwards. So when we talk about retrosynthetic analysis, what we're doing is looking at a product and knowing that that product is from a specific type of reaction, we can work backwards to the start materials. So here, our product is a secondary alcohol, right? And it's the result of a granular addition. Right, so knowing that, there's a way to work backwards to the start materials. Now here, one of our start materials is actually given already. The granular is given, right? But what we need to think about is how to deconstruct the product to get back to the start material. And that's what a retrosynthesis is. Right, so we deconstruct the product to determine the start materials. Let me give you an example real quick. And this is kind of, you don't have to worry about writing this part down, but I want to give you an example. I'm just going to pull up a synthesis paper. See about, well, here we go. Might not be able to pull it. Let me go back and find one that's already available. Because if you ever look at a total synthesis of a biologically active molecule or any molecule, large molecule, what you'll find out is that there's no way to just synthesize that molecule in one step. So normally, typically what happens, I'll come back because the internet is slow. What happens is they'll look at the molecule, the start material, and then they'll break it into fragments retrosynthetically. And then each fragment, they'll come up with a way to make the fragment. But I'll come back to that part. All right, so how do we do this, right? I sent you a video to watch because the retrosynthesis part is not really talked about in the chapter, but at least not in detail. But there's a method that I've kind of developed to help us to understand this. All right, so we're gonna take our alcohol, start with that. Right, the first thing to do, if you're starting with alcohol, is to take the proton off of it. Right, so we're gonna take that hydrogen off. And we'll be left with this. Right, and when we get to this step right here, you can just put in any magnesium source, right? But up here we see that the magnesium source is MgBr, so I'm gonna put that here. All right, now what do we do going from here to here? What is this? Let me put the hydrogen in, and then maybe that'll help it make more sense. What do? We're just working backwards through the addition. What is this species right here in any Grignard addition? What do we call that? Anybody? What happens after the first step when you first add the Grignard into the carbonyl?
Tetrahedral.
My mic is up. Did somebody just say something? Go ahead.
I said tetrahedral.
Tetrahedral intermediate. That's exactly right. So you went from, if you're working backwards through the synthetic process of adding a Grignard to a carbonyl, you go from product to intermediate, and then from intermediate to start materials. Right now, the way that, so once we pull off the hydrogen, this is a method that'll work under any circumstances. If you have an alcohol that's the result of a Grignard addition, this is going to work under any circumstances. So you remove the proton, right? Take that proton off. Now you're here, and then here we're going to collapse this down and put the pi bond back in. Right now, if you look over at the reaction itself, it's showing you what Grignard you used, right? So here, when you do this step, because some of the examples we look at, we're not going to know what the Grignard is. So there'll be multiple ways to do this step right here. But for now, we know that here, if I put that pi bond back, I'm not touching this side, right? I'm going to break this bond right here, because that's the bond that would result from adding this Grignard. Questions about that? All right, so I'm going to do this now. So I'll have, and I'll show this in more than one step. So now I have that with a negative charge, and then this plus. This is my aldehyde. I'm gonna write this CH3 out, even though I don't have it written out up top. And then this is plus MgBr plus, right? And obviously you can see now that these two are gonna get together, right? These two are gonna get together, and that's what that is where your Grignard came from. Any questions about that? All right, so if you combine those two, then you'll have your Grignard start material. Right, so if we were to go back up here, what you would write on this other side is obviously this aldehyde plus this Grignard, even though it's already shown over the arrow, you can still write it in like so. All right, so there's a process. Take the hydrogen off the alcohol to get to the intermediate, collapse the intermediate, and eliminate one or the other of the alkyl groups, right? Or one group or the other. It's not always alkyl groups, but one group or the other on the intermediate, right? If it's a hydrogen, you're not going to eliminate hydrogen. We don't have a way to make a hydrogen grain. There are other ways to add hydrogen, but a Grignard is not the way. So in this case, you'll never touch a hydrogen. All right. Questions? Any questions about anything? I know it's Friday. Okay. Let's work on these down here. All right. Here is my product. How would we deconstruct that product to get back to figure out which aldehyde? And it's a secondary alcohol. So we know that we started with an aldehyde. That's one of the things that we talked about. If you start with an aldehyde and add a Grignard, you're going to get a secondary alcohol. If you start with a ketone and add a Grignard, you're going to get a tertiary alcohol. So this is a secondary alcohol, and it's the result of Grignard addition. What do we do first to figure out which aldehyde we started with? Anybody?
You remove hydrogen.
Off the hydrogen. That's the first step in the process of the retrosynthesis of a Grignard alcohol addition, right? Or Grignard carbonyl addition. You take off the hydrogen, so you get to the intermediate, right? Now what? Right over the arrow, it gave us the Grignard. So which one of these two pieces am I going to break off from the intermediate? I'm not touching the hydrogen, and I'm not touching this part.
Maybe the double bond.
Okay, good. Now let's back up. The maybe is clarified right here because I know that this is what I'm using, right? So if that Grignard is over the arrow, I just need to figure out what aldehyde I started with. I know that that's the Grignard. So it is you don't have to like say maybe, because we know for a fact that it's this part that's coming, this substituent that we're going to remove right here. Now, how do we do that? I agree with you, but I just want you to be confident about that part, because if you know the Grignard, then you know what to remove in the elimination step. All right. So now, how do we remove it? Right. And let me make this point too. Going forward, when you take a Grignard and you react it with a carbonyl, it's an addition. So if you're trying to get back to the carbonyl, it's going to require an elimination, because addition and elimination are like the inverse of one another. So in this step, how do we break off that vinyl group? What are we doing?
You're gonna push the arrow from the oxygen onto the carbon.
Here, like that?
Yeah.
And then what else?
And then you can remove that double bond.
Yeah, I agree. We're gonna remove it, but how? I need another arrow. Is that right?
You show an arrow from that carbon, disconnecting the two carbon bond, the
Yeah.
carbon-carbon bond.
So you show an arrow from the bond to where it's going to stop, to where you want the electrons. I agree. Good. Thank you both. Right. So now that's going to give me this as my aldehyde plus, and I didn't follow my own rules here. What was it over here? MGBR again. So I'm going to stick that out here. I'm going to change the color. Right. So now it's that plus MGBR plus this. Right. So now you know, and this is really an informal way of doing this, but now you know what two things to put together to make the Grignard, right? It would be this and this. So we can show another arrow where now this is my Grignard. Y'all following? Anybody not see it?
We're following.
Let me ask this question. How would you make this Grignard? What two things would you mix together to make it?
Magnesium.
Okay.
Maybe like magnesium iodine and like hydrogen or hydrogen bromide, maybe?
Mm-mm.
Or no? No.
When you're making a Grignard, right? Magnesium is essential. You got to have that. So I agree with that. But how do we make a Grignard from, what do we start with? What have we been studying for the last 2 weeks or so, 3 weeks?
Oh, it would be MG2.
No, you only need magnesium by itself. What I'm saying, what are you going to mix it with in order to get the Grignard? Don't you need some type of alkyl halide or aryl halide or vinyl halide? Is that right?
Right. Okay. So a bromine attached to a carbon bond somewhere,
Not
or
somewhere, but
a double bonded carbon.
yeah, it will be attached here, right?
Mm-hmm.
Those two things together will give you this, right? Because we've been the whole time. Let me recap again. We started out talking about how to make alkyl halides. We said you can make them from alcohols, right? Using PBr3, using HX, using thionyl chloride. Then we said you can add a halogen using allylic bromination. So we got 4 methods to make alkyl halides. Now we're talking about the application of alkyl halide, one of which is to make organometallics like Grignards and Gilman reagents. And then we talked about an application of the Grignard to do coupling and carbon-carbon bond formation or addition to carbonyls, which is what we're talking about right now. So there's a progression as far as what we've been studying. Hopefully you're making the connection between where we started to where we are now, because we started out with just how to make alkyl halides. Now we're talking about how to use them. And there are multiple uses for these types of compounds. All right, let's do the next one. 16. All right, help us out. Somebody help us out. We have the Grignard. That's given. We just need to figure out what aldehyde I started with, or what, no, did I start with aldehyde or a ketone? Look at the alcohol. What type of alcohol is that? You got 3 carbons attached to that central carbon, which we call the carbonyl carbon. You got 3 carbons attached to it. It's not primary for sure. Is it secondary or tertiary?
It's tertiary.
Tertiary carbon.
Here.
So what does that mean in terms of What does that mean in terms of my start material? I know I have a granular, but what am I adding to, a ketone or an aldehyde?
A ketone.
A ketone, good. You're adding to, anytime you have a tertiary alcohol as your product, as the product of a granular addition to a carbonyl, you've added that granular to a ketone. You got a ketone. So we're gonna have to figure out what the ketone looks like. All right, so let's do that. Let me shrink this and get it out of the way. Let's tighten up. All right. First step is what? What's the first thing I do if I'm trying to do a retrosynthesis? I'm trying to work backwards.
Take off the hydrogen.
Take the hydrogen off the alcohol, right? And so I'm going to end up with the intermediate that looks like this. O, that's negative. And then I have this piece. And then this piece. Right, and then it's MgBr again. So I'm gonna put that out here and just let it hang. MgBr. Right, because remember in the intermediate, the magnesium always ends up with oxygen because they form a salt. All right, now what?
You're gonna push some arrows.
We're gonna do the elimination step now, right? What arrows am I pushing? You're right. I agree with you 1000%.
Off the oxygen and breaking the carbon bond next to it.
I'm gonna put that. So I'm gonna restore the pi bond. Is that right?
Yes.
And then I'm gonna break the carbon-carbon bond that will result in this piece falling off or being ejected, right? Because that's my granular. So I already know what granular to use. So I'm gonna do that. Notice the arrows. This arrow stops here between the carbon and the oxygen. That means I'm making a pi bond there. This arrow stops here on carbon. That means I'm making that bond. I'm using the electrons in that bond. I'm breaking it, and the electrons are going to become a lone pair. So these are my two fragments that I get from that. Shucks. This is my ketone. And then plus that. And that's negative. And plus what else? What am I missing?
The magnesium bromide.
Good. Plus Mg. GBr. And we're going to put these two together, right, to make the granular. Right, so that's the granular that we started with over the arrow. Anybody not following or not catching it, not understanding, say something. Okay, let's do this question right here. This is a synthetic question, and we're going to go down and do some more examples of retrosynthesis. We'll be done with this section, and on Monday, we'll probably start the substitution section. That's a fairly long section, but I'm gonna figure out a way to condense it. So yeah, so let's do this problem right here. So it says, and this is a retrosynthetic problem as well, right? It says provide the necessary reagents to carry out the multi-step synthesis shown below. One of your steps will involve hydroboration oxidation. Now, I know y'all get sick of me asking about part one, but we also talked about this reaction in this part. So hydroboration oxidation, these are the reagents for it. What does it do? If we know that, that's the first step to working backwards. This is not the result of an addition of a carbonyl, but there is a step that's going to involve using a Grignard here. Actually, let me cut this out because I want to make sure I don't have to squeeze this in. Dedicate a whole page to it. All right. So what does, even if you Google it at this point, somebody tell me what hydroboration / oxidation does. What does that reaction do? And what functional group does it happen on? Keep in mind, we did this reaction. We talked about it when we did stereochemistry. We were talking about stereo reactions on molecules that had pre-existing stereocenters.
Dr. Russell, is hydroboration the same as? No, never mind. I was gonna say the same as allylic bromination.
No, it's not. That's two different reactions. Hydroboration is, I'm trying to give you a chance to go back to that stereochemistry section.
And so it's adding a boron and a hydrogen to a solution.
Mhm.
And then the boron is replaced with an oxygen. So we create an alcohol.
So it's a way to make alcohols. Is that right?
Yeah.
From alkenes. Right, so now we have a clue. We have a clue of what to do. So this is a way to synthesize alcohols from, one day I'm gonna get me a good stylus and stop using my finger. From alkenes, all right? So if we were to do this in a retrosynthetic fashion, right? We're thinking backwards. It's always the precursor to whatever your existing product is. So if I know that the step to get to this product was a hydroboration oxidation, what that tells me is that the precursor to this product was an alkene, a double bond, right? And it had to be a double bond that was right here. Because hydroboration is anti-Markovnikov. What that means is that when you add the alcohol, it's going to end up on the least substituted carbon in the double bond, right? So if this step got me to the final product, right? The precursor to that is here. Any questions about that? If I take that alkene plus BH3 and hydrogen peroxide, I'm going to get this alcohol in the product. All right, now the precursor to this, the precursor to this product is this. Plus something. First, I'm gonna say the first person, but if you can tell me what that other something is to go from this to this, I will buy you lunch today. And it's not something that we haven't talked about. So it's not some esoteric answer. It's an answer that you would know because it's an answer that we talked about. something that we've been studying.
Maybe it's just
You want to go to Chipotle or you go to Olive Garden? You want to go plain? You said neither one?
no way. Mm,
Think about it. Think about what we've been studying. Actually, we just talked about it 30 seconds ago. We have an alkyl halide. What can I add to that alkyl halide to make this product right here?
probably a carbonyl with the oxygen double bonded or something.
Is there an oxygen in that product?
Oh no. So it
Mhm.
would just be a carbonyl or some kind of carbon with a double bond.
So we want to add this, right?
Mm-hmm.
And make a carbon-carbon bond between this carbon and that carbon. Am I right? Because that's what that is, right? There's a carbon-carbon bond between those two. So what does that, what two things can I put together now? We've been studying this. It should be sticking a little bit at this point. What can I add to that alkyl halide to make a new carbon-carbon bond? I gave you two methods. Right? You can use a Gilman reagent. Is that right? Could you do that? Or you can use a Grignard. If this was a Grignard, wouldn't those two get together to make that? Is this not an example of CM and RX? Is that right?
Oh my gosh.
Mm-hmm. I guess I'll be eating by myself today. Is that not an example of a coupling reaction?
It
Right.
is, and it was on my tongue.
This is an organometallic coupling reaction. Right, we talked about that. You can take a Grignard plus an alkyl halide, an arrow halide, or vinyl halide, and you can couple them together. You can take a Grignard and any alkyl halide, and you can react them together to make a new carbon-carbon bond. All right, so let's see. Let's write out this whole synthesis, and maybe it'll make sense. So this is my starting material. I'm starting with this. All right, this is a multi-step synthesis. We're gonna write it out. I'm gonna write the whole thing out, and then I'm gonna write it out like you would see it in a publication. Guess I'll go to Austin today and add cheese to my veggie burger with all this leftover money. So it's here, right? And I'm gonna add to that this Mg, BRMG, and that's gonna give me this. And then to that, I'm going to add, well, actually, I'm not going to put a plus sign, put an arrow, because this is two steps, BH3, H2O2, and then H. All right, that's going to give me my product, the alcohol. When you're doing organic synthesis, these are the kind of problems you have to work through. You have to work through looking at a product and then figuring out what start materials you added together. But this is an example of a retrosynthesis problem. You started with a primary alcohol, And one of the steps we knew was hydroboration oxidation. So we know that that only happens when you are working on alkenes. So you can take an alkene, make the alcohol, and then the alkene you can make from a coupling. Now, if you were to see this in a publication, the way it would be written to save space would be like this. You would see it. This is I. You'll see an arrow, and then one would be BRMG, like that, and then 2 would be BH3, H2O2, 3 would be NaOH, like that. Right. So it would be a 3-step synthesis, but the hydroboration oxidation is these 2 steps kind of happen together. It's really 2 reactions, right? One to make the alkene, and then one to oxidize it up to the alcohol. But yeah, all right, let me do this. We got 10 minutes left. I want to, any questions about that before we move on? This is a great question. This is the type of question that makes you use all your skills. And that's always a good thing. The more you exercise your skills, the better you become. All right, let's go to here. And let's do, I want to do B, D, and C. All of these, and I'm gonna take cut these out so we can have room to work. All right, and these are all, let's go back up and read the question. It says, provide a retrosynthetic analyses as syntheses for each of the following alcohols, starting with appropriate alkyl or aryl halide. So these are all generated from the ones I picked, because this is from a different book. Some of these are from other organometallic type reactions, but these 3 are the result of Grignard addition. So let's start out with B. And notice we don't know what Grignard we started with. That's what I was saying earlier. Sometimes you'll have a problem where you don't know what the Grignard is, so you'll have multiple routes by which you could synthesize that product. Right? So that's what type of alcohol is that, first of all? That's going to help us understand what the start materials need to be. We got 3 carbons bound to that central carbon. So what is it? Is it secondary? Is it tertiary? Is it extraordinary? It's tertiary. All right, it's tertiary. What does that mean? It means that I have my start materials are going to be a ketone plus a what? A Grignard. Remember, secondary alcohols come from aldehydes. Tertiary alcohols come from ketones plus Grignards. If we're talking about Grignard addition, I'm gonna write that somewhere. I think I wrote it already about 10 times. So for Grignard addition, secondary alcohols come from aldehydes, and then tertiary alcohols come from ketones. right? So if you have a ketone, I mean, if you have a tertiary alcohol, we know that the start material is going to be a ketone and a granular together. So it says 3 ways. Let's do 1 way. Well, first, let's get to the intermediate, because all of any granulars that we do or any retrosynthesis that we do is going to come from the intermediate. Is that right? Because we have to take off the proton here. This is negative, and I'm just going to put a magnesium. What do y'all want to use? Iodine?
Yeah.
Sure.
All right, we'll do that. Now, what's one way? Tell me 1 way. Help me out. Let me know that you have not slept for 45 minutes. What do I do next? I've done the, I've taken off the proton, so I remove the proton to get back to the intermediate. What's next?
Arrow pushing.
We need to push some arrows. I agree. To do what? And
So
let's pick one. What we're gonna kick off to. Let's go ahead and pick that now. What do you want to do? The methyl group, one of the 2 ethyl groups? How do you want to do it? Because you're gonna have to remove one of those groups, right?
Yeah. Yeah. Let's remove the methyl group.
All right, let's do that. So let's see. I'm gonna write it out. So we go here. Is that right? To make the
Mhm.
pi bond, and then here, these electrons are coming to carbon. So I'm going to end up with this ketone plus what? CH3, that's negative, plus what? MgI. Is that right?
Yes.
Then these 2 get married. So the granule is going to be CH3MgI. Yes? That's 1
Yes.
route. Can we do another route?
Yeah. We can do the ethyl group.
Yeah, so let's take this one over here. I'm gonna highlight it. We're gonna knock this one off. So we can do this. Is that right? Would it help if I rewrote this, or are y'all okay with me just changing the colors?
Just change the color.
All right. So we're gonna do that and then that, right? So look where that arrow stops. It's stopping on this atom. So that means I'm making that to a lone pair. And this arrow is stopping between the 2 atoms here, carbon and oxygen. So I'm making a double bond there. Right. So that ketone is going to look like this. Plus this, I'm gonna write it out, CH2, CH3, negative charge on the CH2 plus MgI, and that's positive. And these 2 get married, and that's what my granule is gonna look like. Mg, CH3, CH2, MgI. The reason I wrote this out is because I want you to see that, right? That's the same as here. This is a CH2, and that's a CH3. It's an ethyl group, right? Other side, we did it on the other side, it'd be the same thing. Am I right? If we knock this ethyl group off on this side, it would be the same arrows, just in a different direction. Is that right?
Yes.
All right. We got 2 minutes. Shucks. So you can do the 3rd way. I'm gonna make it purple on my notes, but you can make it whatever you want in your notes. You can do that. All right. What about let's out of time. I really want to do D. Let me just ask this question, because we can pick D up on, we can do D on Monday as a warm-up before we start substitution. What would you do to D in 1 minute? We got a minute left. let me not ask, what would you do? What are the 3 potential pieces that you can remove? Just tell me that in 30
Well,
seconds.
you can remove the what do you call it?
The aromatic ring?
Yes, you can remove that.
Yep, you could. You could
You
also,
remove,
go ahead, I'm listening.
you can remove the ethyl group,
Over here,
and then the methyl group.
yep. You can, all 3 of those are susceptible to elimination if we would have to figure out which gradient we can make, right? Or which gradient added to a ketone. And this is a tertiary alcohol, so we know that one of the starting materials is a ketone, one of the starting materials is a gradient. So we'll pick it up on Monday. You can work on it over the weekend. If somebody wants to share it on Monday, but at the beginning of the class, we can do that. But then we're also going to start, I think the next section is substitution and elimination. So we're going to start that. So that next test is going to be next Friday. It's going to be the same format. It may be on lockdown though, but it'll be the same format. And it'll be granules, well, organometallics, and substitution and elimination, and whatever we did. What did we do before organometallics? I can't remember.
We did allylic bromination and
But that was on, yeah. But the alcohol synthesis was on the on test 1, wasn't it?
only
Some
with
of
high
Yeah,
separation.
yeah, but no allylic bromination. So you're right. So the next test is going to have allylic bromination, organometallics, and then some substitution. We might not finish it because it's a pretty lengthy section. Anyway, we got to go. I'm a minute over. It's Friday, and yeah, we got to stop. Any questions about anything before we depart?